So this chart will be really helpful as you try to make sense of all the formulas that we've been learning. So for volume, for prisms and cylinders, remember it's always your base area, whatever the base is, find its area and multiply it by the height, because you just have that base area over and over again stacked on top of each other, height number of times to fill up that solid. So if it's a cylinder, your base is a circle, so this would be pi r squared for the base area. If your base is a triangle, this would be 1/2 base times height. If your base is a squared, this would be s squared. If your base is a rectangle, this would be length times width. So whatever your base shape is, find its area and then multiply by the height of that prism or cylinder. Pyramids and cones are just 1/3 of that. So you would repeat this process, but then take that fractional part of it, just 1/3. Now, lateral area, remember, is the total area of all the lateral surfaces. So for a prism, the lateral faces are always rectangles. So you could just find the area of all those rectangles and add them together. And remember, you'll have however many that there are will be based on how many sides your base has. So if your base is a hexagon, you have 6 rectangles as the lateral faces. If your base is a triangle, you only have 3 rectangles that are lateral faces. So you could just find the area of those rectangles and add them together. But we do have a formula for finding lateral area of prisms and cylinders, and that's perimeter times height. Now for a cylinder, perimeter, remember, is really circumference. So this would be 2 pi r in place of the perimeter. So that'd be 2 pi r times h. For pyramids and cones, the lateral faces are triangles. So you could just find the area of the triangles and add them together. And remember, the area of the triangle is 1/2 base times height. And again, you'll have however many you have will be based on how the number of sides your base has. So if you have a hexagonal pyramid, hexagons have 6 sides, so you'll have 6 triangles as your lateral faces. If you have a triangular pyramid, you only have 3 triangles as your lateral faces. But we have a formula for the lateral area of a pyramid or cone, and it's 1/2 perimeter times the slant height. Now, this is not the height of the pyramid or cone, it's the slant height. And remember that there's a difference. The slant height's always longer than the height because it's the hypotenuse of that right triangle you create. So it's 1/2 times the perimeter times the slant height. Again, for a cone, the base is a circle, so perimeter is circumference, 2 pi r, and the 2 and the 1/2 cancel. So the lateral area of a cone is pi r l is the formula we use. So surface area, complete surface area, would be whatever you found for your lateral area plus your base or bases, plural. So for prisms, you have 2 bases. So you have 2 base areas plus your lateral area. For pyramids and cones, you only have 1 base, so it's that base area plus your lateral area. So this is a great little review of those formulas and what those variables stand for. And here are some pictures. Remember, prisms and cylinders, volume is base area times height, whereas cones and pyramids is 1/3 of that. And here's our visual to help us remember about surface area, how slant height is used for surface area, not the height of the pyramid or cone. And so that's just a reminder of that. So our wrap-up question says, which has more surface area and why? A right square pyramid or a right cone, where the height and the base area are the same for each. And so what ends up being kind of a difficult problem to look at here, I can show you how we would need to think about this. Where's my pen? Right there. All right, so it's telling you the base areas are the same. Well, the base of a square pyramid is a square, and its area is s squared. The base of a cone is a circle, and so its area is pi r squared. And so it's saying that these two things are equal. And so we could solve for s by taking the square root of both sides. And so the square root of pi r squared, of course, we can take the square root of r squared and bring it out as an r. So we could write this as r square roots of pi. That's what the side length of the square is. So now if I want to look at the surface area, remember surface area will have to do with the perimeter base area. I mean the perimeter of the base. I can't talk, I'm sorry. So if we look at the perimeter of a square, it's just 4 times the side length. If we look at the perimeter of a circle, it's circumference, which is 2 pi r. So we really want to know, are these going to end up being the same, or is one going to be bigger or smaller than the other? Well, we have something we can substitute in for s, and so we can compare these, and that's r square roots of 2. So this would be 4 times r square roots of, not 2, pi. So 4r square roots of pi. Well, 4 times square root of square root of pi can be done in my calculator. And so that is approximately 7.09. So this ends up being 7.09 r. And I can do 2 pi in my calculator, and that's approximately 6.28. That's 6.28 r. So you can see the perimeter of the square is bigger than the perimeter of the circle. And so that means it's going to have a greater surface area than the cone. All right, that wraps up our lesson. Good luck on your homework.